Good afternoon, everyone. Thank you for joining our today's session. We are back again with our another interesting session, which is around Amazon Redshift Warehouse Cloud. This session will be split into two parts. Today we'll be focusing on the part one, which will be more on the foundational, and then we'll have part two in the next month. And for this today's session, we have our guest speaker, Rajas Walawalkar. Before I pass on to Rajas, let me talk about a couple of good stuff, like what's about cooking interesting in AWS UG Mumbai, what we are doing in the backend, and what exactly we do have for you guys. So what's new in AWS UG Mumbai? So first, the whole idea of revamping or having this UG Mumbai is to have the whole idea of networking with experts. We do have different experts in our user group. On the Slack channel, we do have folks from AWS. We have experts across industry who know best practices across different domains, different industries. So you get a chance to network with those experts, learn from them, share your knowledge. There are folks who publish blogs, share about the new things that is happening in AWS, the new services that's coming out, those kinds of different knowledge sharing. You get access to different AWS content. Like we do have the kind of a channel which publish all the white papers and all, any new thing that comes up on documentation, blogs, so you can get to access to those premium content. We do have offline events on Slack, like who's having maximum number of content quality of blogs, who's getting maximum certifications, those kinds of events. We do it offline. Rewards and recognitions, how we have different kinds of rewards. We saw a couple of rewards in our past events. Similarly, we have a quiz today where you got a chance to win credits. So please do stay, don't drop. And as well as you will see interesting events every month. We'll try to be a little bit innovative and try to more go towards foundation and get you towards basic. That's what we have today from Redshift perspective, that we'll start from basic today and then we'll go to the advanced perspective, right? So that's pretty much new about what's in AWS UG. When it comes to us, Slack has been our active channel. So we work in and out on Slack. Slack becomes our primary interactive place. So if you have any questions, queries, you want to reach out to me or our speaker, you can do it on Slack, as well as you can post a comment on the channel where this video will be published. But we do have some other social media platforms like LinkedIn, Slack, Meetup, Twitter, Insta. We do have all the places. So you can subscribe, you can follow us, stay updated what's happening new on AWS in terms of different events. You can have at the rate AWS UG MUM, and you can get subscribed to us in all the forms. If it is possible, please do Slack, join us Slack. I'll post the link of the Slack as well as it's flashing on the screen itself, https bit.ly/join AWS MUM. That's our link. I'll post in the comments as well as. So please do join and make maximum out of it. With that, let me quickly introduce about Rajas. So Rajas is an associate solution architect at Quantify for AWS business unit. Along with that, he's also a community builder. I have a luxury to work with him day in, day out. I can tell you he's one of the best person when it comes to any knowledge around analytics. If you have any questions around data migration, Redshift, Glue, or AWS, any service database, he's a go-to person and expert. And just in one insider thing, this is his first session today. He's very active in the community in terms of his blogs, mediums, open source codes, giving webinars. But for our AWS user group community, this is his first session. So let's learn maximum out of it. And let me get Rajas on the stage. Hi, Rajas. How are you doing today? You're on mute.
Hey Sanchit, sorry for that. How are you? I'm good.
I'm doing good. Thank you for accepting our invitation and spending some time to learn, sharing your knowledge about Redshift.
It's my pleasure. Yeah,
Thank you so much. So yeah, with that, I will just go in backstage and I'll pass on the control to Rajas so we can learn maximum from him. Let me get his screen. Yeah, Rajas, over to you. You can go ahead.
sure.
Best of luck.
Thanks Sanchit. Uh, yeah. So thank you for joining everyone. So I think Sanchit has already introduced me. So I'll just jump to the introduction very short. Um, as Sanjit has mentioned that I'm already working with Quantify Analytics and I've just joined AWS Community Builder in Q1 2022. And this is my first session with the AWS user group. I am, in terms of my experience, I'm specialized in AWS data analytics services, anything related to any data related services on AWS. I've been working through in and throughout all the AWS services related to databases. I have experience in big data tools, and I started my journey as a data engineer. So I have worked hands-on on data modeling, database designing, data lake, and also various business intelligence and dashboarding tools. So that's a very short introduction of mine. I have also attached the LinkedIn and the Medium URL so that you can connect with me at any point of time. That's a very short introduction of myself. Let's jump into our today's agenda. So basically, as Sanchit mentioned, that this is going to be a introduction session for Amazon Redshift. So we are going to look into what is Redshift. Okay, give an introduction towards that. We'll also go through a high level architecture of how AWS Redshift is there at the backend, what are different types of nodes, and what are their specific use cases and everything. Then we are going to have a hands-on session where you'll actually get to know how a Redshift console looks like, how do you play with Redshift, how do you create clusters, create tables, load the data into Redshift, then play with those tables, write some queries, again unload the data from Redshift back into an S3 bucket, and those sort of things. We'll also deep dive into an interesting materialized view concept in Redshift, which is probably going to be an important one, and also do some little bit hands-on with the Redshift materialized view. So let's not waste time in the agenda and everything. I think let's deep dive into the Redshift overview section. Okay. So first of all, what is Amazon Redshift? Okay. So let's understand what is Amazon Redshift first of all. So it's an enterprise-wide, secured, fully managed, scalable data warehousing solution that of course AWS Cloud provides. Let's understand what do you mean by enterprise wide. Okay, so uh, whenever we say that it's an enterprise wide, it means that it's not specific to a single business unit. It's an entire enterprise level data storage which you can use with Redshift. So if I take an example, let's say if you have a university, so a university itself has a number of colleges present under itself. Every college has a different sort of departments, and every department has its own intricacies, right? So if you are understanding the complexity and these the volume of the data that a university will have, that's where you'll go ahead with Amazon Redshift. So it's more specific for an enterprise wide data storage layer. It's fully secured, managed, and scalable. So when we say secured, you can make sure that your data which is stored on Amazon Redshift is secured through different protocols that you have, in transit, at rest protocols, as well as it's fully managed. So AWS makes sure that whatever um, specific type of upgrades or updates that are need to be made on Amazon Redshift, it happens in the backend. And as a user or as a developer of Amazon Redshift, you are not aware of all these things. So it's completely managed by AWS, and you don't have to take an overall of managing such a large, huge scale enterprise wide data storage layer. It's scalable as it's provided by AWS Cloud. So it's scalable. You can horizontally scale the data warehouse as well as you can vertically scale the data warehouse. And that's the very high level introduction of Amazon Redshift. Let's understand what's the application of a warehouse first of all. So if you see the diagram that I have on the slide over here, you see that these are the different stages of where a data goes to a reporting layer. So we have a number of sources. The sources can be database, transactional databases, or the sources can be warehouses or any API based data sources. Then the data needs to be converted into its most processed format. So that's where we'll use an ETL tool. Now ETL tool will responsible to transform the data and write it to a data warehouse. Okay. Once you have an enterprise wide data warehouse, it's a entire dimensional modeling that you perform and create a schema kind of a thing. So there are Snowflake schemas, star schema, different types of warehousing schema that you can design. Once you have the entire data warehouse, you go to the data marts layer. Now data marts are basically more business oriented kind of aggregated tables. You can understand it to be more business oriented. So as we understood that Redshift is an enterprise data warehouse, so it will have data across different business domains, but the data marts are something which are more specific to a specific business domain. Okay. And that's where you can actually use a reporting layer to consume the data from these data marts and do the reporting on top of the data. So that's a very high level understanding of what is a warehouse. And the combination of the enterprise data warehouse along with data mart is something that we call it as a data warehouse. Okay, so let's move on to more specific features of Amazon Redshift. So till now we did talk about what is a warehouse, what is Amazon Redshift. Let's now understand what are the important features because of which the Redshift stands out in all the other warehousing solutions, okay, which are currently present in the market. So it provides you with a columnar data storage. So what do I mean by columnar data storage? So whenever you have huge volume of data, the best way to store the data in the backend is to store it column wise. Rather than storing it in records and in tables, you generally have a columnar storage for Redshift. So relational databases and operational databases are something which where you store the data in form of tables and records. But in a warehouse, we generally store the data into columnar data storage. But you need to understand one thing, that as a user of Redshift, you will see that the data is stored in tables, but because that's how you see it from your end. But in the backend, it's actually a columnar storage only. The reason of having columnar storage is because whenever you write a query, you need to keep in mind that you need to pull only those relevant columns which are required for your actual query, that is for joining and everything. So that's where how you reduce the overall cost by using columnar data storage concept. It supports, it's an MPP, basically it supports massive parallel processing, and that's the reason, because it has a backend architecture. Of course, we are going to deep dive into how Amazon Redshift has its backend architecture. It's a kind of a cluster based. That's where you can use the computing power of all the different nodes which are present in a cluster, so that a parallel processing can happen. If you are well known with the big data technologies where you have Hadoop cluster, in a cluster there are multiple nodes, right? So the way Spark operates on a Hadoop cluster, similar kind of way a Redshift also operates whenever it has to process huge amount of data. Then we have concurrency scaling. So concurrency scaling is a very beautiful feature of Redshift. The reason of having concurrency scaling is that, let's say you are not aware of a specific heavy load that is going to come onto your Redshift cluster. Okay, let's say you have a Black Friday sale, and that's where you need to make sure that your cluster is able to uh, process all the requests which are coming on the Black Friday sale day. Okay, so that is where you will concurrently scale your cluster so that it can horizontally scale as well as vertically scale, and it can process all the requests which are coming from the end user. Materialized view, as I've already mentioned, that materialized view is a very important concept in Amazon Redshift. Generally, who have a database background, we know that there are general views and then there are materialized views. So these materialized views which we have on Redshift are similar to what we have in normal databases, but there are of course some more extra things that Amazon Redshift provides over here. We'll deep dive into materialized views in the later part of our session. And then there is automatic caching. So Redshift itself provides you with a caching layer. Now, as a user, you won't have a control on what data is cached and not. But let's say if you ran a query, which is basically doing a join and aggregation and calculating some KPIs. Now, after sometimes, if you run the similar query or same query, automatically Redshift will not go in the backend and execute the entire query. It will just pull in the data which is already cached in its caching layer. So that's the level of automatic caching it does. And as a user, you don't have to worry and configure about these caching techniques. It happens automatically in the backend of Amazon Redshift. And as I mentioned, that it's a very secured warehouse that is used for any enterprise-wide data solutions. It provides you with at-rest encryption as well as in-transit encryption. You can use different kind of hashing algorithms which are required. You can bring in your own keys to encrypt the data if it's a specific ask. So, in a nutshell, it provides you with a huge number of features. We have listed down a couple of important ones, which can give you an idea of how Redshift is and how does it help you in performing the huge analytics requirement. Okay. Now, let's have a look at the Redshift architecture. Now, this is an important place where we understand how Redshift at the backend actually works. So, Redshift is a cluster. So, whenever I say a cluster, it's basically one or multiple compute nodes along with a leader node. A combination of leader node and a compute node is basically a Redshift cluster. So if you see in the diagram, you can see that there is a leader node highlighted in blue, and there are few compute nodes. So starting from compute node 1 to n, you can scale the cluster at any point of time. So that's the reason we have denoted it 1 to n. Okay. And then there is a leader node. Now, a leader node can connect to your client applications using JDBC and ODBC connections. And what are client applications? Client applications can be any particular uh, um, UI where you connect to your Redshift cluster. Let's say, just to give you an example, for your MySQL database, you generally use MySQL Workbench, right, to connect to your database, run some queries, create some table. So your MySQL Workbench becomes a client application for your MySQL database. Similar to that, Redshift will have a number of client applications that it supports, using which you can actually connect to your Redshift cluster, submit a query, get the output, create some tables, and do pure analytics on top of it. So let's now understand what is a leader node. Okay. So a leader node is basically a very important part in a cluster, and this is the leader node which actually manages the communication between your client and between your compute nodes. So just to highlight specific things, your compute nodes are never in communication with the client application. Only leader node will communicate with your client applications, and leader node is responsible to actually dedicate all the tasks to the compute nodes. Okay. And just to make you a little more clear about how the Redshift cluster is. So a data, whenever you create a table on Redshift cluster, it's not stored in a single compute node. Your data gets distributed across different compute nodes that is there. Okay, it's basically creates a partition. So if you understand it from an Hadoop point of view, where you have a master node and slave nodes, the data is always distributed across the slave nodes, right? Now, here, if you see, the leader node is also responsible to understand and to maintain the statistics of a single table, just to remember like which type of data is stored in which particular compute node. And there is a reason why a leader node needs to store that table statistics. That is because it has to understand which particular compute node will be performing which task whenever a query is submitted to the leader node. So uh, basically, if I go into the uh, other functions of the leader node, what happens is that whenever you submit a query to a leader node, it basically creates a query execution plan. Okay, now query execution plan basically divides a single query into multiple subtasks, and using the table statistics that it has, it understands that this particular task is something that can be computed by compute node 1, and this task can be given to compute node 3, something like that. So that's how it decides which compute node performs which particular task, and it accordingly assigns those tasks to the compute nodes. Now, what happens once the compute node processes all the tasks and gives back the result? The result is again taken back by the leader node, and it will compute that different sub solutions that are provided by the compute nodes into a single result, and it will give it back to the client application. uh, for a You need to understand that leader node is going to be an important part of your cluster, and that's the reason it needs to be fault tolerant. And what does Amazon believe is that Amazon will make sure in the backend that your leader node is replicated across multiple different data centers, so that your leader node, even if a particular node goes down, it already has a replica in some another place which can be pulled up, and it can work as it is. So this is a type of a management that Amazon has to do in its backend. You are not need to worry about anything, and it automatically is fault tolerant for your usage. So that's the entire idea of how leader node is placed in a Redshift cluster. Now let's understand what is what are compute nodes. Okay, so as I mentioned, that compute nodes are the ones who actually perform the tasks and calculate the different queries and everything. So what happens is that a compute node, you can understand a compute node to be as a normal machine itself, or a virtual machine which has its own RAM, which has its own CPU memory, and its own storage layer where the data or the partitions are stored. Now, whenever a task is assigned to the compute node, what it will do, it will use its own computation power to perform that particular task, and it will create its own intermediate result. And that intermediate result is sent back to the leader node so that the leader node can actually compile the result and give it back to the application. um, Another thing that we need to understand over here is that you can go on adding more and more compute nodes as and when required. So Redshift overall is a pay as you go model. So you no need to worry about, let's say you're starting a new project right now, and currently you do not have an idea in the future, like after 2 or 3 months, what is going to be my scale and how much data I'm going to consume. If you do not have that foresight, it's completely fine if you want to start small. Okay, so for now you can start with a 2 node cluster or a 1 node cluster depending upon your current data volume, and as and when your data volume increases, you can go on adding multiple compute nodes. You can horizontally scale it as well as vertically scale it. So it's a completely pay as you go model, and that's the beautiful thing of Amazon Redshift. um, as now we have understood the entire architecture of Redshift, let's understand what are the different types of compute nodes. It's also important to understand the different types of compute nodes that you have. So the first one is a dense storage type. Now, what is a dense storage compute node? This particular compute node you will prefer when you have huge data volume. Okay, and whenever your data storage requirement is actually more than your compute requirement, that's where you will go ahead with a dense storage compute node type. Okay, and dense storage will have a hard disk attached to it. Now you need to understand that hard disks are generally more slower than the normal SSD disk that we have, right? So generally hard disks are used for huge storage requirement, while the compute is not so heavy, and that's where you'll use a dense storage. But a catch over here is that dense storage is a very older version of compute node that Redshift has. Currently, AWS has a new type of a compute node, which of course we are going to discuss it in few slides ahead. It's an RA3 type. So AWS personally recommends that you use RA3 types rather than going ahead with 10 storage, as it provides you with good huge amount of storage as well as huge amount of compute capacity. So just to give you an idea of what are different types of dense storage as well as what are the configuration it has. So if you see that it gives you around 4 GB or 4 virtual CPUs and 31 GB of RAM. Along with that, the storage per node that you see, it's around 2 TB. So you see that the computation, that is the number of CPU and the RAM is less, while the storage is very huge. If you see the second node type, it gives you 36 CPU as well as 244 GB RAM, while the storage that it gives is 16 TB of hard disk. So that's where you will use a dense storage type. If you look into the next storage type, it's more specific to dense compute. Now, this type of node you'll use when you have a huge compute requirement, okay, where the compute requirement is more than your storage requirement. And that's where the disk which is attached to your compute node is an SSD disk. So as SSD disks are actually created for very high performance, high throughput, input output from the disk, and that is where SSD is used for the dense compute. Now, what does dense compute provide you? Basically, it gives you with a good amount of compute requirement. So if you see it over here in the image, your storage is less. Okay. Now, if you see the storage is around 160 GB, while your compute and your RAM is very huge. You have multiple different types of dense compute as well, and this is where how we can select a specific node type depending upon your actual use case. So let me just take a pause over here. I think I've covered a lot of content. So we went through an overview of Redshift. We also went through the architecture, how it's designed, and we went through the different types of compute nodes we have. I have also left with one more compute node type. So it's basically RA3. As I've mentioned earlier, that AWS prefers and recommends to use RA3 node type rather than using a dense storage. The reason for this is that it provides you with good compute as well as good storage. So just to give you an example, that the storage that it provides, it's of 32 TB, as well as the compute is very good. So it actually overpowers your dense compute as well as dense storage. And RA3 nodes are very more comfortable to use with. It uses S3 as a backend. So automatically you mean that your hot storage as well as cold storage data is segregated, so that your hot data remains into your compute nodes while the cold data moves on to the Amazon S3. So this with this actually I am coming to an end with the entire compute node types. So before I move on to the next section, are there any questions that you have in your mind? You can put it into the chat window or you can ask me those questions. Let me take a
So,
pause over here.
uh, thanks for this. I think that's going good. There are two questions what we have from the audience in the chat. So the first one is, I am a beginner and I have a query. Can we create star schema warehouse? Uh, if we are creating a star schema warehouse, do we still need to create the structures like fact dimension tables in cloud warehouse?
Uh, that's a very good question, actually. So you need to understand that star schema is just a design thinking or a design model, right? At the end, a warehouse has facts and dimensions. So where just to give you an idea that warehouse is built on the terms of dimensions and facts. Okay, now the way in which you use these dimensions and facts is something that is dependent upon a star schema and the snowflake schema, right? Now the star schema is where you have one fact table and multiple dimensions, okay, and it looks like a star, while snowflake is where your dimensions are more normalized, right? So just to answer your question, dimensions and facts are always going to be a part of any warehousing data model, and it's not specific to star schema or snowflake schema. It's a generic data warehousing term that we use, and that's how a warehouse is actually created.
Thanks. We have one more question. Do cloud warehouse handle streaming data?
A good question, actually. So let me answer you in this way. So generally, if you need to understand this, so um, a warehouse is majorly built for pure analytics. Okay, now analytics is done majorly on very huge data volume and a historic data. So data warehouse is generally used for historic data storage, while transact OLTP and transactional databases are used for current data, where you can have updates and everything. Now, streaming data is a completely different type of a data ingestion mechanism. So, streaming data can be used with Amazon Redshift and with Warehouse. That's not a problem at all. But you need to think of how you load the data into Redshift, okay, or on any particular warehousing service. Reason is, as warehouses are built for historic data, so bulk load is always preferred in any warehousing service. Okay, if your streaming data is there, you kind of need to change it into near real time. Okay, so it's not going to be with a second latency. You can take small buffers of 2 minutes or 3 minutes, aggregate or combine the data of 4 minutes in one particular batch, and then load it onto a warehouse. So that way what happens is that there is not degradation of performance on the warehouse. See, of course it can easily handle the streaming data, that's not a problem. But if you're looking from a performance standpoint, you need to make sure that you do not degrade the performance of the warehouse, and that's where those micro batches is going to help. So you kind of define a micro batch of 4 minutes or 5 minutes. You kind of store it in your buffer memory, the streaming data for 5 minutes, and after a 5 minutes window you load the data into your Redshift. So that way your Redshift performance also does not get degraded, and you also get a near real time use case rather than a real time.
Thanks. There's one follow-up questions what we have. Could you please tell Redshift is for which profile in IT industry?
Oh, okay. So Amazon Redshift is basically a data warehouse, right? So data warehouse is for all the developers who are present in the IT industries who are currently working on pure analytics, SQL based analytics, and who are working as a data engineer or SQL developer. So those kind of profiles. So let's say you have data engineers, you have SQL developers, you have even your BI developers are someone who would require to use Redshift, okay, because they are closely working with the backend data along with the dashboards and everything. So these are some of the profiles where Amazon Redshift or any particular warehouse will be used. Any other questions?
Yeah, I think there's one more question. What we have is, what is the preference of Redshift over Snowflake?
Oh, nice. So that's a very very good question. So I cannot see. It's not how. Uh, there is not a single answer to this particular question. Okay. So you need to understand what's your complete use case. Okay. You need to understand what are your requirements, and depending upon that, you need to draw a line of distinction between Redshift and Snowflake. Both of the warehouses are very well known in the market. Okay. In our projects we have few implementations on Redshift, we have few implementations on Snowflake. So there is not a single answer to that. Okay, you need to understand what are your requirements, what are your access patterns, what are your downstream applications who are going to consume the data, and according to that you need to take a call. So both these services and both the offerings are equal in nature. Majority of the features which are present in Redshift are also present in Snowflake. So you cannot actually take a direct call. Of course, you'll have to see, look from a costing perspective as well. Okay, while deciding, and then understand and then take a final call. Any other questions, Sanjay?
No, I think that's all what we have. I think we can continue.
Cool, awesome. So let's now continue with our session. And this is where I think the things are going to get more interesting. So let's start with a good hands-on experience and workflow on Redshift. So before we go, actually there are a couple of prerequisites that we have and that we need to follow over here. Okay. um, I have mentioned it in the deck, as well as I'll be sharing a link, a GitHub link that I have created, which basically includes all the steps that I'm currently going to follow in this particular hands-on session, so that in your own time you can actually go through that GitHub link and perform that particular hands-on session on your own time. Okay, so that's how I have planned it. A couple of things, of course, you need to have admin access to your AWS account. At least, even if you do not have an admin access, you need to make sure that you have full IAM permission so that you can create IAM roles, and you have full access to the Redshift service of AWS account. Okay, these are the two important requirements. So you need to have full access of IAM, and you need to have full access of Amazon Redshift. The data set that I'm currently going to use in this session, I've downloaded it from Kaggle. Okay, you'll have to download it. It's a very commonly used data set. It's the NYC taxi data set, which we're going to use in this particular session. Okay, and then there are further two steps where I'm going to show you in the hands-on session itself. So let me just go to the AWS console. I'll have to sign in again. Let me just sign in. 1 second. I'll just stop sharing my screen and we'll be back with the console signing. Give me a minute. Yep, I'm starting to share my screen now. Yes. Can you see the screen?
Yes.
Yep, I think it's visible. So, yeah, so this is the AWS management console. Okay. So, let me start with the list of prerequisites that we have. Okay. The first thing that we want to do over here is to create an IAM role. So, let's go to the IAM service. You can search it over here. Let's open it in a new tab. Okay. Now, basically, we need to create an IAM role so that your Redshift cluster, which we are going to create, can communicate with other services which are present, and which we are going to use in our hands-on session. So this is the IAM console. Let's click on create role. Once we click on create role, you can go down, and over here we need to select Redshift. Redshift. Once you select Redshift, you can click onto this radio button of Redshift customizable. Click on next. Here there are few already managed and defined Amazon policies. We are going to use same policy. Just click select Amazon Redshift, and then you need to select this particular IAM role. So this is Amazon Redshift, all commands full access. Now this is a IAM role which is already managed by AWS. We no need, there is nothing that we need to do. We just need to select that particular uh, policy, and then we are going to give a name to your IAM role. So let me cb underscore Redshift 101. Okay, let me create a role will be created in just few seconds. Okay, yeah, so the role is created. You can see cb redshift 101. Okay, now the second important thing that we want to do over here is to create an s3 bucket. Let's click on s3 service, open up the S3 console. So S3 bucket we are going to create just to store our input files, okay? The files which we are going to load it onto a Redshift cluster. So those particular files we are going to store it in a bucket. Let me create a bucket over here. Give a name to your bucket, cb hyphen redshift 101. Okay. Uh, Keep other things as it is. Okay. Let's just click on create bucket. Hope that the name is not taken by any other user. Yep. Okay. So you need to just note that you need to make sure that the bucket name should be unique. So I've created a bucket named as CB Redshift 101. Okay. If you are going to create the same name bucket, then you are not. Then the AWS is not going to allow you. Reason is that the bucket names are a unique namespace. So you need to give a unique name. So I was able to create bucket with this particular name. Okay, let's just go into that bucket and create a folder. So let's create a folder named as nyc dataset. nyc dataset. Within the folder, let's go into the folder and let's just upload the file that we downloaded from the cattle set. Okay. uh, Select the file. The file name would be train.csv. Okay, the file name would be train.csv that you have to select, uh, and then just click on upload. It might take few minutes to upload because it's of 193 MB. So let the file get uploaded. Till that time, we'll just go to the Redshift console now. So till the time the file is getting uploaded, uh, let's go to the Amazon Redshift service. And this is where we actually get started with the creation of a Redshift cluster. Let the console open up. Yeah. So this is a Redshift console. Let's click on clusters over here. You can see all the previous clusters that you have. Let's just create a new cluster. Okay. So let the name be Redshift cluster 2, not an issue altogether. Uh, yeah. So this is a selection that we need to just keep in mind. Okay. So there are different types of node. Okay. So these are the different types of node that we just went through our deck. Okay, so these are the ds2. Here you can see that it's already marked as legacy. Then there are dc2 are all the compute node types, and then there is ra3. Okay, so this is where I think AWS recommends to use ra3, but for this particular session, let's just select dc2 large. Okay, we are going to do it on a very small node cluster, so I'm just keeping dc2 large, and I have selected number of nodes to be just one node. uh, it can show you like what is the cost that you are going to incur if you keep the cluster running 24 into 7 for entire month. Okay, so it's going to cost you $180. Then you need to provide a specific username and password. Let me just put in very generic username and password. And then here you have an associate IAM role permission. So you need to click on associate IAM role, okay? And this is where you're going to select the IAM role that we created in our prerequisite spot, okay? So we created the CB-Redshift 101. Let me just select that IAM role and associate it. Okay, so basically this IAM role that I'm going to attach the cluster will have the permission to communicate with S3 bucket, and the S3 bucket is where we are going to store our raw data through which we are going to load the data onto the Redshift cluster. So that's the reason the Redshift cluster needs to have the access to um, pull the data from the S3 bucket. Okay, let's keep all the network configurations as it is, but this is where you can actually do all your networking stuff. You can make sure that you're locking down the Redshift cluster in a closed VPC in a private subnet. You attach different security groups and firewall rules. Okay, but for now we are going to keep it as it is. Let's not complex the entire creation of cluster. Okay, I'm going to click on Redshift cluster. It's going to take a while because it's a cluster at the backend, right? So it needs to spin up the compute nodes, leader nodes, and everything. So it will take some time to spin up the cluster. But till that time, let's just explore an important feature that we're going to use. So if you see on the left hand side panel, there is a query editor version 2. Okay, so let's just right click and open it onto a new tab. So this is a visual editor. So Amazon provides you with a web-based visual editor where you can use it to connect to your Redshift cluster and basically work with it. Okay, so it's an important thing because you not need to install and configure any specific type of applications on your local machine to connect to your Redshift cluster. You can directly do it from this console itself. Okay, that's a more easier way of doing it. So just to give you a small walkthrough of the entire visual editor. So here we have different sections, databases. You can see that we currently have two database clusters. Okay, the second one is the one which which we created just now. You can have queries over here. Okay, so you can even save your queries. So I've already saved my queries. You can create different notebooks and everything, and then you can actually visualize the data in the charts as well. Okay, so let's say you get the output of the particular query, and if you want to visualize that particular output of the query, you can do it from this section as well. Let's just check whether our cluster is up and running. It's currently modifying. It will take some time. So here if you see, there are multiple options. Okay, so you have a create option, you have a load data option. Of course, that's not enabled because we haven't selected a Redshift cluster. So that will be enabled once we'll have the Redshift cluster to run it. So what I'm going to showcase in this session is that how do we create tables on Redshift? Okay, load the data from S3 to that into that particular table using queries and commands. So that's one way of doing it. The second thing that we're going to do is that create a table using this entire visual editor. Okay, so instead of writing those create table queries, we can easily do it using the visual editor over here, and we can also load the data using this visual editor. So I'm going to show you both the ways of loading the data. Okay, yeah, so if you see, the Redshift cluster is now available. Now we can connect to the cluster. We just need to click onto this cluster, it will automatically connect. Okay, uh, once it connects, so here, so once it connects, actually you can click onto this drop down icon. Here you see that there are two default databases that it provides you. Let's just click onto them, and then you have a schema, that is a public schema. So if you see the hierarchy, this is a cluster, then this is the database, and then this is the schema. So generally it's a kind of a way where Postgres database is, where you have database schema and then the tables. Similar to that, it's similar to how it's there in the Postgres. Okay, and here if you see that there are tables into it. Okay, so let's just open up the query that we have. I'm going to keep it over here. uh, I already have both the tables in my public schema. Let me do one thing, let me just drop the tables. So it's not there. Let me just refresh it. Let's open the database again. Oh, okay. So currently we do not have any tables in the public schema. Perfect. Now let's start with the creation of the table. Okay. I'm going to uncomment this particular query. Okay. If you see this particular query, it's basically showing you how do you create a table. Okay. It's a simple thing. There are two important concepts over here. The one which I'm highlighting, distribution style and distribution key. In the next session that we are going to have, we'll be discussing it in more detail, and it's a very important thing whenever you're trying to create tables on Redshift. So for now, let me just run the query as it is, so that it can create the table. Okay. Uh, the table creation is successful. You can refresh this particular panel so that you can see that the table is created or not. Let me go into dev public. Yeah, if you see, then I already have one table, that is taxi rides. Okay, let's now check whether our S3 bucket has the file uploaded to it or not. So this was the file that we uploaded. Okay, train.csv, it's there in the S3 bucket. Let's go back to the UI, and this is the copy command. So copy command will be used to load data from any S3 buckets to your Redshift tables. Okay, here what we'll have to do is that we'll have to update the path. Okay, as we have created a new bucket altogether. Let me just copy the name of the bucket and put it over here. And I'll also have to update the IAM role. Okay, so this is the IAM role which we created in the previous section. So CB Redshift 101. I need to copy the ARN from here, go back to this console, and I'll have to paste the ARN. Okay. So this is the S3 path. This is the IAM role. The format is CSV. Okay, the format of the input file, and I've placed ignore header as one. Now, why do we have ignore header as one? Because the CSV already has a header row, and I do not want to include that as a data row in my table. So that's the reason I'm asking the copy command to ignore that first row. Let me just run this. It will take couple of seconds to load the data. As you can see that the size of the files was around 190 MB, but it takes just 8 seconds to load the data. So that's the power of doing a bulk load. Okay, so whenever you have huge number of records, it's always better to do a bulk load rather than doing inserts. So copy at the backend uses bulk load. uh, Here we have the successful execution of the copy command. Let's just verify the table whether we have the data in it or not. Okay, so the data is properly inserted. So this is how we actually create a table. We use a copy command to load the data into the Redshift table. Okay, and this is how you can actually work with the tables, and it's very easy to create tables. The syntax is very similar to the other queries. Now the second way in which I'm going to show to create a table, it was through a UI. So let's just drop the table again. Okay, let's drop the table, and now let's create a table using the console itself. Okay, the drop table was successful. Let me just comment it out again. Now if you see, I have a create option. When you click onto that, you can have an option of create table. This gives you an UI based upload. So I'm going to select a schema. The schema is public. I'm going to rename taxi rights, and here you can give the entire schema of the table. Now, generally, it's very difficult to add each and every row and select the column name, the data type, and everything. So, a better way of and an easier way of doing it is that you can click on to load from CSV. You can just browse onto your local machine where you have that CSV. Okay. Once you browse to that particular CSV file, it will automatically detect the schema from your CSV which is present on your local machine. Okay, so if you see, I already got the schema automatically because I choose the CSV which we want to create a table. Okay. There are a couple of changes that we have to do before we uh, create a table. So pickup date time is something that it has identified as varchar. We'll have to change it to timestamp. Let me do that. Even drop off timestamp, I'll have to update it to timestamp. Okay. And then id we need to use it as a primary key. So what how you can do it, you have to just click onto the column name and just enable this primary key button. So automatically now id becomes my primary key. Let's just click onto table details further, and this is where we define the distribution key. So let me choose distribution key as id. Okay. And the distribution style will automatically become as key distribution style. Let's go back. Now let's click on create table. So basically it creates a table in the backend. Okay. If you refresh this, we will be able to see the table dev public schema and the tables. Okay. So we have already have a table. Now let's do one thing. Let's load the data into this table using the console now. Now I'll click on to the load data. I have to browse to the S3 bucket. Okay. So let me just select the S3 bucket. So this was the one which we created. You have a subfolder inside it, NYC dataset, and then you have the train.csv. So let's select this. Okay. Um, then we'll have to, it's already, we'll have to choose the IAM role. So the IAM role is already the one which is connected to your cluster. File format is already CSV. We do not need to make any changes to this. We need to go and select the data conversion parameters. Now here you have that option of ignore the headers. So let's just click onto this option and select, click on, just enter one over here. It's already one. So we are going to ignore the first header in the data set. Okay. Go back to load data. Then we need to select the schema and the table in which you have to load the data. Once you are done with this, you have to just click on load data. So if you see, it automatically creates a copy command itself in the backend. So you can do it using a copy command, write the entire command. Otherwise, you can do it directly from the console. So the copy command was successful. Let's just go and again select select this. Okay, you can see that the data is there. Perfect. Let me now show you another thing. Okay. Now, once the table is there, let me show you how a create table as query runs. Okay. So, a create table as query is a very similar, is the same thing that we have in other databases. Okay. So, it's a very common thing. Basically, what we do is that we have a query, and if the output of that query needs to be stored in some another table, then we use a create table as query. Okay. So, if I just run this select query, it's going to give me a aggregated table. Okay, so this is where what we have done is that by across every date for every hour, we are just calculating the number of trips, number of passengers, total trips duration, and the max trips duration. Okay, now what we want to do is that we want to store this output that we got over here into a table itself. So let me run this entire query, and here if you see, we are creating a taxi ride date hour table. Okay, so here the query ran successfully and the table will be created. Let's just refresh the left hand side panel, go into the dev public. Okay, we already have two tables right now. So one is the original table and another one is the create table as query that we used. Okay, so we created an aggregated table. Now let's say if you want to unload this particular data of this table into S3. So you already also have an unload command. So this unload command is very easier to use. It basically includes a normal query. So instead of giving select star from, you can also give any other query that you want to unload the data from the Redshift cluster. So basically you have to provide the query, then you need to select the S3 bucket. Okay, let's just change the S3 bucket which you have. It's the CB Redshift 1 and update the bucket name over here. And let's also update the IAM role. So IAM role, we already copied it from the previous copy command. Okay, let's just paste it over here. Yep. So this is the unload command which is ready, and we are using header and CSV. These are the two indicators. Basically, header means that I want to include the header in that CSV file, and CSV, basically you can unload the data in form of CSV, JSON, Parquet, any specific format that it supports. So currently we are going ahead with CSV. Let's just run the unload command. Okay, the unload command is successful. Let's go back to your S3 bucket and just refresh it. So you see the automatically a new subfolder was created, rs unload output. And if you see that the entire table is now pushed onto S3 bucket in two different files. Okay, so you can even control how many number of partitions you want to create on S3. So that all things you can add it to your unload command. Okay. So this is how we actually unload the data from the Redshift cluster as well. Further, we have materialized views. Okay, so let me just switch back to the presentation again. Okay, let me just switch back to the presentation. We went and created the IAM role. We created the S3 bucket, the Redshift cluster, created the table, loaded the data, as well as we used the create table as query and the unload command. Now we are left with the materialized view. Let's go ahead and understand what is a materialized view. So materialized view is basically uh, created on the concept of you compute it once and you use it multiple times. So that's the entire concept of materialized view. So basically it's a nothing but a normal database object where all the pre-computed results of a specific query are stored on the database, so that next time whenever you use that materialized view, the query does not run at the backend, but all the computed data is fetched and given back to the input query. So that's how the entire processing of the materialized query runs. There are the features of the materialized queries are it obviously pre-computes all the KPIs, okay, and it stores it into the database. You can refresh materialized view queries. Okay, now whenever it stores the data, and let's say your base table changes in the backend, you need to refresh the materialized view, because if you do not refresh the materialized view, it is going to give you the stale output of the aggregated KPIs and the values. So if you want to get up to date aggregated value, then you need to refresh the materialized view, and there is a simple command that you need to just run to refresh the view, and automatically you will get the refreshed output. It supports incremental refresh. Now that's an interesting thing, because if you understand that, let's say you are having an heavy join, okay, between two tables, and then you're aggregating some data. uh, if that query itself takes time to complete the entire processing and store the result into a materialized view, and if you refresh that view, it might take huge time to again recompute everything, right? But what happens in the backend is that Amazon will not do a complete full refresh. It will do an incremental refresh. So what does incremental refresh mean? That only for the new records that are inserted into the base table, the entire query will run, and it will append that the aggregated data to your actual materialized view. So that's the reason why materialized views are very faster, as well as the refreshing of it are faster, because it happens only on the incremental data. And interesting thing is that you can use materialized views on materialized views. So let's say you created a materialized view by joining two tables, and if you want to use that materialized view in another view, then you can use that directly. So it's not necessary that you can only use tables in your materialized view, but you can also use other materialized views in your queries. Let's understand a use case for materialized view. Okay, so let's say this is an events table that you have. Events table, understand that it's a normal dimension table. We have an event ID and an event name associated to that event ID. Then we have a sales data. Now sales data, we can consider it to be a fact table. Reason, because we have a price column into that. Okay, now price is a fact, right? It's a KPI. That's the reason it becomes a fact table. Now here is what we want from this table. Okay, we want to calculate the total sales by event. So if you want to calculate total sales by event, what you have to do, you have to join events table and sales table on event ID, group by on event name, and then do a sum of the price. Okay, so that's the solution, and that you can do using a materialized view. So what you will do is that you will create this query and you will create a materialized view out of this query. So automatically what will happen, tickets MV is a materialized view which is created on Redshift, which already stores this pre-aggregated data. Okay, now again, if you have a question, right, let's say going ahead my new events are added, my new sales are added, then how do you tackle that situation? You can refresh the materialized views. Okay, so it has to be done by using a simple command. You can use that refresh materialized view and the name of that materialized view, and it will automatically incrementally refresh your view. Okay, and one interesting thing that Amazon is now supporting, of course, that particular feature is in preview, it's not in productionized. It that materialized view are also now auto refresh materialized view, so that what will happen, it will automatically detect that there are changes in your base tables and it will automatically refresh your views. So you do not need to manually go and fire that command of refresh, it will automatically happen. But this particular feature is currently in preview, and of course once it is productionized, I think it's going to be a very useful command. So let's just switch back to our view queries. So here is what we have, our materialized view. Okay, let me run some of the query. So what we have done over here is that I've taken the same query. Okay, so if I just run this particular select statement, it's the same query that we created and unloaded uh, into this particular thing. There was an error. Okay, no worries. Let me just run this entire query again. So this was the same query which we ran earlier to unload the data back to S3. And what we are going to do is that we are going to save this result in a materialized view. So if you see the query syntax, it's the same: create materialized view, you give a name to your view, okay, and then you write the entire query. So let me just run this entire query again, and here we have the materialized view ready. So let's query the materialized view. Okay, let me just comment this particular thing and comment this and just run select star from materialized view. So it's going to fetch me the result which is already pre-aggregated. Okay, so that's how you get the query from the materialized view. Let's comment out this particular query, and I'm going to show you the query which you can use to refresh the materialized view. So it's a very simple query: refresh materialized view and the name of the materialized view. So let me just run this query, and what will happen in the backend is that your view will get updated. Okay, now currently it's not going to help anything because we already have all fixed tables, there are no new data which is coming. But just to show you like how simple are these commands, you can just add it to your refresh materialized view. Okay, even you can schedule this command so that after every hour, if you're having an incremental data after every hour, you can just refresh your materialized view. So that's how you can actually do a couple of things on Redshift. Okay, um, I am almost done with all the things I had for this particular hands-on session. So just to give you a complete summarization, we did create a cluster, we create tables on Redshift, and then we actually used copy commands to load the data. We selected the tables as well as we used create table as query. We unloaded the data back from the Redshift cluster back to S3, and then we used materialized views, how to create those views, how to select from the views, and how to refresh the views. So that's an overall high level way of working with Amazon Redshift. Okay, let me switch back to the presentation again, and this is where we actually end our presentation. uh, Let me just stop for a second. If you have any questions that I can answer, Sanchit, are there any questions from the viewers?
Yes, Raja. So we do have a question here from the audience. Uh, I think this is continuation what your the previous question
Mhm.
was. Fact dimension tables are necessary for every warehouse, as Redshift is a columnar warehouse
Mhm.
and it's much faster than raw format Oracle warehouse. Then why should we create facts dimension table in Redshift? I mean, many fact dimension table created just to increase performance in raw format data warehouse.
Okay, so that's how we design a particular warehouse. Okay, so let's just first understand that facts and dimension, as I mentioned, that those are some generic concepts. Okay, you can, if you do not want to call it as facts and dimension, you can call them as tables itself. Okay, so instead of creating and putting all the data into a single table, it's always better to segregate the tables across multiple tables, right? So that is how we actually design an ER diagram. Okay, that is how we actually design an OLTP or a transactional database. Similar to that, when you have a huge historic data that you want to store in your Redshift cluster or on any warehouse, so the best way of doing it is to segregate the data into multiple different dimensions, and then you have a single fact table where you can actually get the KPIs which are required for your analytics. Now there are other concepts in a warehouse such as SCDs, right? So slowly changing dimension. Now how do you tackle such situations, right? So let's say your OLTP systems are where you update the data directly. You do not store the history of the data. But Redshift or any particular warehouse is where you store the historic data. You need to understand how my data changed over a period of time, right? So this is where you use SCDs, slowly changing dimension. And for such type of scenarios, it's better to use facts and dimension, because that is how you can maintain history of different dimensions. You can add multiple flags and everything, and you can store the history of the data, which can actually give you a huge analytics standpoint. Okay, now analytics is always done on the historic data, and it's not done on a transactional data, because you need to analyze your historic data points and understand what are my business outcomes out of that, how can I improve from that. Okay, so that's the overall logic of having facts and dimensions. You can call it as simple tables. There is no need to call it as facts and dimensions, but it's a generic way of creating a warehouse. I hope I answered that question.
Seems like yes. So, guys, if you have any other questions, please put it in the chat. Just will be happy to answer them. And yeah, please continue. We will have a quiz. We'll have a quick round of quiz, and the winners will do get AWS credit. So please do stay with us. So let me go ahead, share my screen. I think what we can do, we can start with the quiz. We can take the quiz, and in meantime, if you have any questions or queries, you can put it in the chat, and that just will pick it up once we are done with the quiz. So let me go ahead and share my screen. Second. Just check this out, guys. So I'm just starting the quiz. Just give me a second. I'll share the link in a second. So yes, I've posted a quiz link in the chat. So please, guys, do join as well as join with the name, so it becomes very easy for us to identify who are the winners. And let me go ahead and share my screen. So waiting for the players to join. Please do join the quiz. We have AWS credits for the guys for the first two winners of the quiz. We'll pause for a few more minutes and then we'll begin. So I think we do have good number of people there. Let me quickly start with the quiz. So I'll go ahead and start the quiz. We'll have 5 questions and we'll have 2 winners from the quiz. This is session 1 and here we go. What does MPP stands for when referring to the type of architecture of Redshift? Option A, massive parallel processing. Option B, massive protection policy. Option C, massive parallel policy. Option D, massive protection processing. So we have 6 right answers. Let's see who's at the top. So we see Rob is at the top. Awesome. Let's go with the second question. Redshift can provide fast query processing by leveraging dash storage approaches and technology. Option A, key value. Option B, database. Option C, row. And option D, columnar. Time's up. We have 7 right answers. Let's see who's the winner here. So we see a change here. Sam is going to be a winner here. So we have Sam and Ram as the winner. Let's go with the next question. Question 3. Adding nodes to a Redshift cluster provides dash performance improvement. Option A, linear. Option B, non-linear. Option C, both. And option D, neither. So we have 1 right answer. Let's see who's that person. So Tanmay has given the right answer and he has jumped into the second position. And Sam continues the first position. Let's go with the fourth question. Amazon Redshift has how many pricing components? A4, B3, C2, and D5. Redshift has how many pricing components? So we see 1 right answer. Let's see. 0 right answer has given. The right answer is 3. Let's see the status of scoreboard now. So there is no change. And this is the last question. What type of API provides a management interface to manage data warehouse cluster programmatically? Option A, queries. Option B, REST. Option C, management. Option D, SOAP. So we see 1 right answer, which is query. Let's see who's the winner of the quiz. Ram is the second winner. So Tanmay is the second winner. Sorry, Ram is the third. And who's the winner here? Let's see. So Sam is the right winner here. So we have two winners here. Congratulations to the winners. We have Sam, Tanmay, and Ram are the three winners here. Guys, please do join our Slack channel and send me your email ID. The link I've given in the chat. So we'll send you the Amazon credits to the first two winners, which is Sam and Tanmay. So please share your email IDs on our Slack channel, and we'll ensure that your credits have been given forwarded to you. So that's what we have from the quiz. I'll stop sharing my screen. If you have any questions for Rajas, please put it in the chat. So we have few more minutes before to wrap the session. So if you have any questions for Rajas, please put it in the chat. This is a part one. We'll have one more session, part two, for more advanced concept of Redshift, which will be scheduled in June. Please do join us on Slack and follow us on all the social media platforms, so you stay updated with the notification. I hope you guys like the session for today. Please post the questions in the chat. So yeah, I think we don't have any questions, so we can wrap up. Thank you, Rajas, for spending your time from this valuable from your weekend from Saturday. I know Saturdays are much more, you have some time to spend your family. So thank you so much for pulling out a time. Thank you to all the wonderful audience for staying with us for this entire an hour, over an hour kind of session. I hope this session you guys liked it. Please, if you're watching this in a recording form, put the questions in the chat. I will ensure all the questions in the comment have been answered, as well as join a Slack workspace. Rajesh, me, as well as our experts are already on the Slack workspace. So do join us. As I mentioned, we'll have one more hour session, which part two, which will be more around how you can productionize your Redshift cluster, the performance tuning section, which is very important. We'll schedule that in June. So please do join our social media platform and do subscribe to our different events. That's all what I have from AWS User Group Mumbai for today. Thank you so much. Uh, have a wonderful evening and stay safe. Thank you.
Thank you. Thank you guys for joining. Thanks a lot.